Hello, everyone, and thank you for joining us for today's session. My name is Danny, and I'm the event planner for the New York Reactor Space. Before we start, I have a few things to go over. Please take a moment to review our code of conduct. We seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional, and on topic. Useful links will be shared in the chat. The session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. It will run for approximately 30 minutes with time for questions throughout. I will now turn it over to our speaker for introductions.
Hi everyone, good afternoon, good morning, good evening, wherever you are in the world. Today is Series 3 of Model Monday. So I'm Lee Starr, I'm a Principal Cloud Advocate Manager. Unfortunately, I'm not Nitya. Nitya is in the background today, so Nitya is answering all our questions on LinkedIn and on YouTube. So we are streaming on those two channels today. As Danny said, this session will be recorded and made available on demand after today. So if you do have any questions or you want to follow up with us, please do talk to us in the Discord and on the GitHub discussion. So as always, we have Shamila here with us today to talk about models. And we also have our guest, Mohan Japili, from the Phi Models team. So Mohan is going to talk about what her experience is with the Phi Models. But first of all, let's get started with Shamila and talk about Model Monday. So hopefully you've all been to Model Mondays before. This is episode 3 of Series 2. Each week we try and break down a different aspect of the Azure AI Foundry model catalog and talk around specific model features, services, or tooling to help you get started with your AI developer and AI engineer experiences. We host those on Mondays, hence the Model Mondays name, and then we do a follow-up on Fridays, which is an AMA. But because this week is the 4th of July, it's a pretty special day for those people in the US. As you can tell, I'm not in the US, but we're going to have Foundry Fridays now on Thursday. So this Thursday we'll be hosting Foundry Thursdays with Mohan talking about the Phi models, but we'll come into that in a little bit more. So if you are interested, please check out Model Mondays. Please register for future events. You can see all the different activities we have coming up. So Shamila, over to you for our weekly highlights from Azure AI Foundry.
Thank you, Lee, and welcome to Model Mondays, your weekly roundup of what's new in Azure AI Foundry. So again, we're going to talk about what actually matters to you in this week's highlights as a developer. We have 5 updates this week, all high impact, low fluff, and as usual, every highlight has a QR code. So take a screenshot of it, and that QR code usually takes you to a blog or to a GitHub repo or even to the model card, depending on what the news is. So let's get started. So first up, Azure AI Foundry just launched safety leaderboards. It's a big step towards responsible AI. We did have a model leaderboard announced a few weeks back, and it had things that you could check for performance, latency, and cost. But now we are taking a big step towards responsible AI. This new addition to the leaderboard lets you evaluate and compare models based on safety benchmarks like jailbreak resistance and prompt injection resilience. You can now make informed decisions, not just on performance and cost, but also on trustworthiness before they bite you in prod. So it's a great step if you're shipping anything that's customer facing in production, or if you're shipping things in regulated industries or domains. Moving on. Next is Foundry Local, and it's now in public preview. So Foundry Local has Azure hosted models that run entirely on your infra. So you can now deploy LLMs, vision models, and more in a container with no internet dependency. It boots instantly, works in air-gapped settings, and brings AI to edge use cases without latency or compliance trade-offs. Next highlight is Model Context Protocol support. So last week we talked about MCP support in Foundry models. Now today we are going to talk about MCP support in Azure AI Agent Service. So if you're built with multiple models in production, you know how routing logic can get really messy. And MCP support lets your app reason about context and route tasks to the best model automatically. So fewer if-else blocks, more intelligent abstraction is what you get with MCP support in Foundry Agent Service. Now moving on, we've not been talking a lot about fine-tuning in the past few months, but recently fine-tuning in Foundry just got a serious boost. So we have rolled out new models and also new capabilities like reinforcement fine-tuning with O4 Mini, supervised fine-tuning for GPT 4.1 Nano, and then fine-tuning support available for Llama 4 Scout models, which we announced last month. And this means you can lower cost, do faster training, and better results with less data so you don't torch your budget or the data. So it's perfect for customizing performance without retraining from scratch. And finally, a quick shout out. Microsoft has been named a leader in the 2025 Gartner Magic Quadrant for data science and machine learning platforms for the second year in a row. This is the big validation of the Azure AI platform and its commitment to building tools that scale across AI lifecycle from experiment to production. And that's a wrap. Whether you're working on edge AI, agent routing, or fine-tuning, Azure AI Foundry has real tools to speed up your build cycles. So see you all next Monday in another set of highlights. And I'm going to hand it over back to Lee. Thank you.
Thanks, Shamila. So again, great update there from the product team around different things that are happening in Azure AI Foundry. Again, a big call out, in terms of the Gartner Magic Quadrant, Azure AI Foundry is now within the top sector of the quadrant. So again, lots of activities happening. Please do check that out. Shamila, have you got any other key insights or updates for us live on air?
Yeah, live on air. So there are, just watch out in the next few days. We have more models dropping. So
a new day, a new model.
Yeah, exactly. So I'll come back next week. But for now, I think we had a really good set of updates. A lot of things happening on MCP. So I'm guessing folks will be interested. And last week we had the MCP episode. So that's a continuous drumbeat that we're doing. So please keep an eye out for that. Yeah.
Excellent. Yeah. And again, with MCP, we've launched the MCP for beginners, which is a hands-on guide if you're interested in working with MCP from being beginner to very advanced. And we cover things like security, what is MCP, how to use MCP. So please do check that resource out on our Discord channels as well. So huge thank you, Shamila. So let's move over to our guest. So today we're going to do our weekly spotlight. And we're going to be talking about small language models, so SLM, and specifically the new reasoning models from the Phi team, so the Phi 4 reasoning model. So Mohan Japili is from the actual Phi team, so she's from the product team, and she's one of our senior researchers in Microsoft Research, so the actual team behind the development of the Phi models. So I'd like to welcome Mohan to the stage, and we've got a great session lined up for you, and then we're open to Q&A. So great to meet you, Mohan. So give us a bit of background, who you are and what do you work on?
Hi, thanks, Lee, for the introduction. So I'm a senior researcher at Microsoft Research. We, do pre-training and post-training on small language models, and our hope and kind of goal is to bridge the gap between frontier models and SLMs and try to kind of match the performance in a lot of areas. And the main motivation behind SLMs is that they are much easier to fine-tune and customize for, downstream tasks that folks are interested in. They're much easier to iterate on and much more efficient and kind of cheaper to do large-scale inference. So we are really pushing the capabilities of these models and trying to see what is possible with them.
I've got a question before we go into your demos. So if you're going to explain to someone a small language model versus a large language model, what are the key characteristics?
That's a great question. And I think that we are constantly shifting the definition of SLMs as well. Maybe back in 2023, SLM would have been anything below maybe 3 billion parameters. But as the hardware and also the demand for the capabilities has grown, I would say that we are kind of becoming more ambitious on how many parameters we allow our models to have for an SLM. But I think as a general guideline, we would like to have models that can run typically on commodity hardware, such as a laptop, or maybe not like a state-of-the-art GPU. So I think as long as we can host our models on settings such as that, then I think we can fall within the definition of SLMs. But like I said, as the underlying hardware and the frameworks for inferencing becomes more mature and more customized, I think that we can push the definition of SLM to even more larger models as well.
Excellent. So we'll go into your demo, and hopefully we'll get some questions, and we can have a bit of a Q&A after the demo. So yeah, let's see the demo.
Hi everyone, my name is Mohan and I'm a senior researcher at Microsoft Research AI Frontiers Lab. And today I wanted to talk to you about our most recently released models, FIFO reasoning. Before going into the details, I wanted to first explain what reasoning models are and why are they important. So the core characteristic of the reasoning models is that they follow explicit logical steps in order to solve the problems. And that means that they decompose a complex problem into sub-problems in order to solve each of the steps. And this is kind of similar to how humans think. And they work by iterative refinement, meaning that they constantly backtrack and double check and verify that the previous steps that they've taken to solve the problem have been correct. And if not, they make them correct. And all of this happens through an explainable process. So all of these models are generating what we call a thinking trace that kind of shows you all of the rationale and the reasoning path that the model is taking to reach the final solution. And this is especially helpful if you want to verify where the answer comes from and double check everything step by step. So because of the capabilities that I just described, reasoning models are really well suited for complex decision making. And this involves mathematical reasoning, like solving equations and proofs, strategic planning, like multi-step problem solving, algorithmic thinking, like developing systematic approaches, and also logical analysis, where you need to evaluate complex arguments. Now let's take a look at the 5 reasoning models. Late last year, we released the FIFO non-reasoning model, which is a 14 billion parameter dense decoder-only transformer architecture. And all of the FIFO reasoning models are built on top of FIFO through a specific post-training process. The first model in the family is FIFO reasoning, which is fine-tuned on more than 1.4 million STEM and coding questions. And FIFO Reasoning Plus is a further enhanced version that has a short reinforcement learning step. What is special about the FIFO reasoning models is that they're really competing with models that are 5 to 50 times larger their size while maintaining superior efficiency and performance per parameter. And they have an extended context length of up to 32,000 tokens that allows them to go through complex reasoning chains and comprehensive problem analysis. And at 14 billion parameters, they're actually very suitable to efficiently run even on commodity hardware such as laptops. FIFO reasoning family have unprecedented reasoning capabilities that outperforms larger open weight models and is competitive with some of the state-of-the-art models despite being only 14 billion parameters in size. So for example, we are better across the board compared to DeepSeek distillation of Llama 70B and better on most tasks compared to Claude 3.7 while having superior performance compared to Gemini 2 thinking. And we've evaluated our models in various reasoning domains, including mathematics, scientific reasoning, coding and programming, algorithmic problem solving, planning and scheduling, and spatial understanding, as I'll talk about later today. And so far, we've seen really strong community adoption with more than 30,000 downloads for FIFO reasoning on Hugging Face and 84 quantized models contributed by the community, and 24,000 downloads on FIFO Reasoning Plus with 26 quantized models. And the most popular quantized variants is the Onslaught GGOF version, which has 120,000 downloads so far. And we have been receiving really strong positive feedback online and from the community as well that talk about the reasoning power of these models and how they outperform larger models on math, logic, and coding, how they have a clear chain of thought, which is intentional, and it's easy to follow the multi-step outputs that the model is generating. They are very efficient in deployment, and the value of the open weight, which allows the community to run local inference. It's free and accessible, and also allows them to do fine-tuning and various specializations on top of this model. The community also appreciated our rigorous benchmarking, and in fact, all of our benchmarking code is open source and available online. And also they have contributed various quantized versions, as I mentioned, such as the Onslaught version, which have been very, very helpful and popular. Now, in order to train for excellence, we have 3 fundamental pillars and steps in our design process for the 5-4 reasoning models. The first step is data curation, and it starts by collecting and filtering high volumes of data. And when we do this collection and filtering, we are really focused on 4 different strategies. The first one is that the prompts should be teachable, so they're selected to have the optimal complexity and diversity in order to teach the most content to the model. And they're really selected to be at the edge of base model capabilities in order to kind of boost the performance of the model to the max. And we really filter for high quality and have a high bar for quality control when we are selecting our data. And we make sure that we cover a lot of the domains that we want the model to be good at, such as STEM, coding, and also safety-focused tasks. And once we have gathered our prompts and questions, we generate detailed reasoning chain of thoughts using O3 Mini as a teacher model. And these high-quality step-by-step demonstrations are later shown to the model in the training data in order to achieve that problem-solving capability. And we really focus and emphasize on data mixture, and we do a strategic combination of different domains and difficulty levels and different data sources in order to make sure that our models are, comprehensively capable across multiple problem types. And the data mixture is essentially a carefully balanced mixture across various domains to ensure broad reasoning capability and robust performance. And the domains that we consider in high level are STEM, which is science, technology, engineering, and mathematics. We have coding, which is focused on algorithm design, problem solving, code generation, and debugging. And finally, safety, which focuses on content moderation, ethical reasoning, harm prevention, and responsible AI. And when designing these data mixtures, we are really careful on creating it, and we emphasize on data quality over quantity. And we acknowledge that the data mixture and the training recipe are actually fundamental to the success of the model. The second stage of our training is supervised fine-tuning, and we actually have a multi-step process for this one as well. The first step is exploration, where we are really establishing our training recipe, and we focus on doing a lot of ablations and experiments on single domain data sources, and we also really tune our training hyperparameters and just the general training algorithm. And we had a couple key insights during our explorations, which is that synthetic data actually improves the final answer precision a lot, and we find it to be very helpful, as we have outlined in the technical report as well. And we noticed that reasoning-specific system messages actually boost the consistency and performance of the model. And that is why in the model card, we actually suggest a system prompt that the model has been trained with and encourage everyone to consistently use that specific system prompt. And we also noticed that as the model becomes better and the quality improves, the response length decreases as the thinking process becomes more efficient and coherent. And we also noticed that there is an additive property across domains in the data mixture where we can really individually optimize the data sources within one domain and then confidently combine all of the domains together in one final run. And that brings us to the second stage, which is really the scaling up of the training and inference. So in this space, we really combine all of the data from all of the different domains that we've optimized previously. We use a better teacher model and allow essentially an inference time scaling of the teacher model in order to generate longer responses. And we support these longer responses to allow our model to solve more complex problems by thinking more. The final stage of our training is a short reinforcement learning using outcome-based rewards with verifiable solutions, which enables the model to learn from the success and failure patterns of the answers that it's generating. And we really focus on math problems, and we select 6,000 high-quality mathematical problems to conduct the reinforcement learning over. And what we observe is that throughout the reinforcement learning, the length of the reasoning traces actually increases, and the model generates approximately 1.5 times longer reasoning chains while providing more detailed step-by-step problem-solving approaches. And this really provides an accuracy versus efficiency trade-off to the users, where the reinforcement learning checkpoint offers higher accuracy at the cost of increased token usage. And this really is a choice between efficiency and performance. So we really have two models and two strategies, and the users can choose between efficiency and maximum accuracy based on the specific use case. So on the one hand side, the supervised fine-tuned model, which is 5-4 reasoning, is efficiency optimized, and it uses tokens efficiency. It has faster inference and lower computational costs, and still a very strong reasoning performance. So this is well suited for fast, lightweight logical reasoning and structured problem solving with lower latency. And 5-4 reasoning plus, on the other hand, is accuracy maximized. So it has higher accuracy, especially on math-related questions, with longer reasoning traces and more detailed explanations that have on average 1.5 times longer generations. And this is really best suited for handling more complex, multi-step reasoning tasks with improved accuracy and a broader generalization. Now let's take a look at the benchmarking of the models. So the 5-4 models, including the reasoning and reasoning plus, have all been rigorously benchmarked across two primary categories. The first one is reasoning specific capabilities that focus on tasks that benefit from this step-by-step problem solving and logical reasoning. And the second one is general purpose capabilities that are broad abilities, including simpler reasoning and other behaviors. Now, the most popular benchmarks that are evaluated for the reasoning models are mathematical reasoning. And in that front, the first one is AIME 2025, which is a qualifier for the USA Math Olympiad. And this exam is actually contamination-free because it came out after we had already gathered our data sets and trained our models. And as you can see, we actually have performance on this benchmark that is comparable to the full DeepSeek R1 model, which has over 50 times more parameters compared to 5-4 reasoning models. The second set of problems is HMMT, or Harvard-MIT Mathematics Tournament, and what is exciting to see here is that we really outperform the distilled version of DeepSeek R1 in Llama 70B, which is 5 times larger, and we also outperform O1 Mini and O1 from the OpenAI models, as well as the original DeepSeek R1. And similarly on OmniMath, which has more than 4,000 Olympiad-level problems in algebra, calculus, geometry, and number theory, we have over 40% improvement over the base model, which is the non-reasoning 5-4, while outperforming O1 Mini, O1, and also Llama 70B. The second set of benchmarks are for scientific reasoning, and GPQA is graduate-level Google-proof Q&A benchmark that has expert-designed questions and answers in biology, physics, and chemistry. And on this benchmark, you can see that the 14B models have better performance than O1 Mini and the distilled version of Llama 70B reasoning on these PhD-level questions. And finally, for coding, we evaluate Live Code Bench, which is a challenging coding benchmark, and we see that we have over 25% improvement points on this benchmark compared to the non-reasoning 5-4. Another thing that is worth noting is that the models have strong generalization to out-of-domain tasks as well. So what we did was we took the models and we started evaluating them on reasoning benchmarks that are really out of distribution with respect to the data that we have trained the models on. And that includes 3-SAT or 3 literal satisfiability problems, which are solving NP-hard problems. And we saw that we actually had 60% improvement compared to the base non-reasoning 5-4 model. Similarly, for the traveling salesman problem, which is again an NP-hard problem, both of the models were able to get more than 30% improvement compared to non-reasoning models. And finally, for calendar planning, which essentially tries to find a common time slot given a series of complex constraints, we have 50% improvement compared to the base non-reasoning model, even though, again, none of these tasks are things that we explicitly had in our training data. So this really suggests that once the model learns reasoning as a meta skill, it can generalize and apply it to new domains that it hasn't seen before. And we also saw really good performance on general purpose benchmarks, even though, again, these were not targeted in the post-training process. For example, these models have improvements compared to the base architecture in instruction following, in long context question answering, and also just in general in terms of human preference, which is represented by the ARENA hard benchmark. The reasoning models also performed really well on information retrieval tasks as measured by the Kitab benchmark, and they're also really good in terms of safety and responsible AI measured by the Toxigen benchmark that kind of sees whether the model can detect toxic content and whether it can correctly identify neutral content on the other hand. And we saw consistent improvement across these different benchmarks compared to other models, as well as the base non-reasoning model. Now let's take a look at the use cases given all of the benchmarks that we've seen so far. And the reason why we think FIFO reasoning is really amenable to use is the fact that it's competitive with much larger models despite being only 14 billion parameter in size, which make them super efficient and compact to do inference. And we've also noticed a lot of transferable skills where reasoning not only improves in the domains that we've targeted with our training data, but we also saw improvements on out-of-domain tasks and also general purpose tasks. And we've shared all of our methodology through a technical report that we think will help advance the entire field and kind of help boost that research and development. And in terms of use cases that we envision for FIFO reasoning plus and FIFO reasoning includes intelligent tutoring system that require a personalized math and science tutor with step-by-step reasoning to solve complex problems, show adaptive learning paths, and also run efficiently on tablets and devices. And also scenarios that require autonomous agents that can handle logic-heavy reasoning for complex multi-step problem solving. And this includes planning and execution, self-reflection capabilities, and in fact, our models are already being used in some of the open source autonomous web agent frameworks. And we envision people to build on top of the FIFO reasoning models in order to further pursue the research and accelerate the research as a foundation, as well as in order to test scientific hypotheses and perform data analysis and gain insights. And finally, we envision it being able to be used for customer service and support, like intelligent routing or a fallback assistant for high-volume customer interactions that can handle automated ticket classification or complex query resolution. We also think that FIFO reasoning can be integrated in next generation development tools, for example, in order to help with software development, such as code generation and debugging, and help users understand the code better with detailed reasoning chains that kind of explain the different algorithmic approaches and also help them optimize different strategies for the code. And in fact, our models are already being used in autonomous coding agents. And the models can also help with automated code review and get integrated into systems that can identify the errors or suggest optimization and ensure just overall high code quality. They can also be used for strategic planning and complex scheduling, like project management, resource allocation, timeline optimization that has different constraints and different priorities, or various methods or flavors of resource management, like optimizing human resources, equipment allocation, budget distribution, and this includes various complex organizational structures and project requirements. And in terms of summary and key advantages, FIFO reasoning models are able to do multi-step problem solving and break down the problem into subproblems in order to solve it better. They have internal reflection and self-evaluation in order to double-check the process and their own solutions. They have strategic exploration built into them in order to test multiple approaches before solving the problem. And they also support inference time scaling and generate longer responses as needed in order to tackle the task at hand. And they have also some business advantages, like the fact that they're cost effective and they outperform variants that are 50 billion parameters, 5 times larger and above. They are enterprise ready because we have really had a safety focused training and we have built the safety safeguards inside of the models. And they are easily customizable for specific business needs by running additional fine tuning on top of them. And they do provide reasoning at a small scale. You can enjoy fast deployment because of the smaller size and faster inference. They are device friendly and run on tablets and laptops and phones, and they're small and compact. This concludes my talk, and I would like to thank all of you for attending. And here are some of the resources in case you're interested to kind of learn more about the FIFO reasoning models and the project.
Great, thank you. We've got some great questions from the audience. So, overview of the models there was really comprehensive. And I think, one of the first questions was, would a small language model be better to incorporate on edge devices? And you touched a little bit on this, but could you go into a bit more details about, are they available in CPU, GPU, MPU variants?
Sure, absolutely. So I think we have quite a few different quantized versions that have been, contributed from the community as well as Microsoft. So Microsoft recently introduced like some Onyx optimized models that are int4 quantized. We also have some other variants that are available, and I believe that we are sharing the links with the audience that I encourage them to take a look at them. They're available in VS Code, AI Toolkit. We also have some quantized versions available on Hugging Face that folks can download and take advantage of, like 4-bit, 16-bit, and 8-bit quantized variants by Onslaught that have been very popular as well.
Excellent. Yeah. So we've got more details around AI Toolkit next week. So if you are interested, please come on to that session. Another question was, why do you think these small language models are so good with mathematical reasoning?
I think that mathematical reasoning is kind of just an interesting and maybe lower hanging fruit, but it doesn't necessarily, it's not an end goal for these models. And it's just to showcase that they are able to perform, rigorous steps and break down the problem into, sub problems, and able to double check and kind of test multiple different hypotheses at the same time. And the fact that they are doing well on mathematics, I think, is encouraging because it shows that they can also apply the same meta skill of reasoning into other domains as well. Like, we are very excited to explore more on the, agentic tool use that we are actively working on and conducting research on, and also other areas that I mentioned in the talk.
Excellent. So this really brings me on to our next question is, can small language models be trained to recognize and alert for dangerous symptoms clusters using real-time biometric, such as wearables?
Sure, that's a great question, and I think that one thing that like the answer is definitely yes, but I think an interesting nuance here is that all of these SLMs and even LLMs are trained on natural language. So I think that one thing that we would need here is kind of like a wrapper that translates the biometrics and the sensor information that has been gathered from the wearable devices into natural language explanation of what is happening, and then we can definitely use these models to go over the transcript and kind of categorize and pick up the important signals and try to kind of give alerts or just do general classification.
So the final question, we've got two questions which are very similar, so I'll put them together. So the question is, one's about healthcare. So can you use a small language model to enhance patients' triage, clinical decision-making in telemedicine environments? And the other one is around finance. And this is like, can SLMs be used in finance? So I think they're both sort of are very good questions because they're linked to fine-tuning of models. So do you want to talk a little bit about, you had a very good highlight of, producing fine-tuned models in your session, but can you go into a bit more detail of how someone can take a model and then fine-tune that model for a specific task?
Yes, absolutely. I think that like a lot of the general capabilities are baked into these models, but I think that, as users come up with their own evaluation for their own tasks, they can see some shortcomings in some areas, which can definitely be, patched with fine tuning. I know that the general methodology that we, carried over to teach the models, mathematics or coding, the same kind of concepts apply. You can do, supervised fine tuning on, little amounts of data, and you can already see, big boosts happening on certain areas and certain evaluations. Reinforcement learning is another very promising avenue to fine-tune the models, although it can be a little bit tricky to kind of get right. So I would suggest, start by evaluating the models, see where the gaps are, try to generate data that exactly targets those specific skill gaps that you're observing, and then start with supervised fine-tuning. And we have many great frameworks for that as well available that we can link on Discord channels for folks if they're interested. And then finally the cherry on top would be reinforcement learning.
Brilliant. So we've just got another question around the Phi Silica models. So Phi Silica models now ship within the Windows AI PCs. And the question is really around, utilizing the Phi Silica. Now, I know Phi Silica is out of a different team, But again, it's the same process. You would use something like LoRa to fine tune that using the AI toolkit.
Yes.
Do you want to sort of explain the family of the 5 models? Because there is quite a lot of 5 models now, isn't there?
Sure, yeah, absolutely. And I think that we actually work very closely with the Windows team who's shipping the Phi Silica model. We are, sharing our data, and in fact, we are actively doing a fine-tuning and reasoning fine-tuning on one of the models that they pre-trained for them, and working very closely. So I think that in high level, we have quite a few different, models in the series. We have Phi 3 models that actually have, different sizes, and we have Phi 4, which was recently released at 14 billion parameters. So these are kind of the general purpose SLMs. And then in the reasoning family, we have the 2 kind of reasoning and reasoning plus models. And we also have a mini reasoning at 4B parameters that folks can use if they're interested. And like you mentioned, we have, different optimized versions as well. For example, for Windows, which is, handled by the Windows team. And like you mentioned, we are actively working with them. They are working on quantized versions of the model as well for inference, and a lot of LoRa fine tuning.
Yep, excellent. And again, lots of resources in the Phi cookbook to cover the whole Phi series family of models. So yeah, lots of resources, lots of information. And again, we will be having a further discussion on Thursday in the Discord channel. So our next session next week will be with the AI Toolkit team. We've talked a little bit around AI Toolkit and how it can be used for development and for agent building, and also fine-tuned models. So Leo Yao from the AI Toolkit team will be here with us next week, and the host will be April. So April will be hosting next week. And then on Thursday, we've got Mohan back, and we're going to be talking much more detail around the Phi model. So please do join us on the Discord channel. We'll be there. We're going to have 30 minutes. It's going from 2 o'clock Eastern time on Thursday, not Fridays this week. And we will be talking more detail, more depth. So please do ask your questions. We'll be recording questions today from anything that we've missed. They'll be going on to both the Discord channel and the GitHub discussion channel. Again, please ask your questions and bring them to the session on Thursday, and we hope to see you there. So thank you to our guests today. It's been a great pleasure in hosting this series, and thank you for Nita being in the background. Here's some QR codes if you want to watch this content on demand. If you want to join our AMAs, which are typically on Friday, just Thursday this week. And if you want to find a recap of what we discussed today, we do have that posted onto the forum. So there's the QR codes for you to utilize and hopefully enjoy Model Monday. So we hope to see you all on Thursday. So huge thank you.
Thanks, Lee. And thanks everyone for listening in.